Hello and welcome to BrainAtlas, the modern one demands constant learning and complex problem solving. But for many individuals, especially the ones who are neurodivergent, who deal with anxiety, or just have a poor working memory, retrieving information under pressure or on demand can be an overwhelming barrier. When you hit a mental block, standard study tools or chatbots just give you a wall of text, but they don't help you understand why you're forgetting those things and how those things connect with the global picture. People who struggle with memory retrieval need help bridging the gap between abstract mental blanks and concrete visual mental models. And this is why we built BrainAtlas, an adaptive patient multi-agent cognitive sparring partner designed to visualize your mental map. Let me quickly walk you through the architecture. BrainAtlas isn't just a simple LLM wrapper. It's a multi-agent architecture built using the Google Agent Development Kit, and it uses an MCP server knowledge base as the ground truth for questions, rubrics, and curated study resources, eliminating LLM hallucination. It uses two different agents, an interviewer agent who drives the conversation with the users, picks the question or any follow-up questions depending on the evaluator agent score, and the evaluator agent score, which acts in the background, scores your answer and gives back the score to the interviewer agent. At the end of the session, a deterministic graph mapper takes the evaluator's grading and deterministically translates it into graph nodes. Let's dive into the live demo now. So in this demo, I'm starting a session. An interviewer agent engages me with a concept. This demo is focused on a system design interview. You can see a knowledge graph of my past sessions. Once I get a question, as the conversation progresses, BrainAtlas is physically mapping my cognitive gaps. By the end of the conversation, the node dynamically will scale in size. The more I struggle with a concept, the larger and more prominent the node becomes. It turns invisible anxiety into a concrete, manageable visual map. Let me just skip through till the end of the conversation, where actually the session is ended and the new knowledge map is persisted. Here you can see that we are just finishing the session and the BrainAtlas updates the knowledge graph with the new nodes or scale the nodes according to the new scores. But we don't just point out flaws. If I click on this struggling node, a drawer slides out with highly curated domain-specific study resources. And these aren't LLM hallucinations. These are pulled deterministically from our MCP knowledge base. We also wanted to show how the agents interact with each other. So we've built a secondary trace visualizer UI to monitor the raw agentic tool calls and state transitions happening under the hood. So you can see that here I'm engaging in another conversation with the interviewer agent. And as the conversation progresses, you will see that the evaluator agent is called in order to score the answer. I'm just gonna quickly go forward so that you can see the actual calls. So you can see here the evaluator agent doing its job, getting the rubric, extracting the gaps, and then rendering the score to the interviewer agent, which will pick up a new questions until the end of the conversations where the session results are persisted and the new knowledge graph or the knowledge graph is updated. In conclusion, BrainAtlas represents a massive leap forward for cognitive accessibility. By leveraging specialized communicating agents and a grounded MCP server, we have created an endlessly patient sparring partner. Thank you for watching.